Okay, 6 review. And these first several problems, you have your choice of how you want to solve them. It doesn't matter if you solve them by substitution, by graphing, or by elimination. It's up to you. It's your choice. So you can see number 1 here, I decided to solve it by substitution, but I also did it by graphing, and I'm going to show you that here in a second. Okay, since both of these have a variable by himself, it doesn't matter which one's the bread and which one's the meat. So I just let the y equals x plus 6 be the bread, and then the y equals x plus 3 be the meat. And if this is what y equals, then I plug it into the y. Remember, if you have variables on opposite sides of the equals, you have to move one of them. So I moved my positive x by subtracting it. And then those x's went away. They just gave me 0, shoop, 0, shoop, eliminated. All you have left is 6 equals 3, which is a false statement, so there's no solution to this problem. And that's how you do it by substitution. So like I said, it doesn't matter which one's the bread and which one's the meat. So I could have had these flip-flopped. It wouldn't matter. And then I also solved this by graphing, so I want to take a second and I want to show you that. So at the bottom of one of the pages, it's below question number 17, there were some empty graphs, and this was if you wanted to solve your problems by graphing. So that's what I did. I did it by graphing just in case anybody else did that. One of them had a y-intercept of 6, and the slope is 1. So up 1, right 1, up 1, right 1, or down 1, left 1, down 1, left 1. The other equation had a y-intercept of 3 with a slope of 1, up 1, right 1, up 1, right 1, or down 1, left 1, down 1, left 1. You can see that these lines are parallel, which is another reason how you know that there's no solution. And I also knew that they were going to be parallel because these two lines have the same slope. Parallel lines have same slope. So whenever your lines have the same slope, your lines are going to be parallel, and parallel lines never touch, so no solution. Or you can give me the 0 through the slash through it. So I solved that one just a couple of ways I wanted to show you. Okay, number 2, I decided to solve by graphing, so I'll just show you the graph. I didn't do it any other way. So this is my number 2. I just rewrote my equations off to the side here. This one has a y-intercept of 3, so I went up to 3 and plotted that. And then the slope is negative 5 over 3, which tells you to go down 5 and right 3. So that's what I did. I went down 5 and right 3. I also went reverse, up 5 and left 3. My other equation has a y-intercept of negative 3, so I came down to negative 3 on the y-axis and plotted that point. And then its slope is 1/3, which tells you to go up 1 and right 3. So up 1, right 3, bam. The two lines intersect right there, which is the point 3, negative 2. So number 2, I thought it was best for me to solve by graphing. I could have done substitution with it, but I didn't really want to because of the fractions. Okay, number 3. I did this one 2 ways. So first I'm going to show you the substitution method. So let me flip back. So number 3 I did by substitution, and then I also graphed it, so I'll show that to you also in a second. Okay, once again, it doesn't matter which one's the bread and which one's the meat because they both have a variable by itself. So I let x equals 2 be my bread and the other equation be my meat. Since this is what x equals, I plug it in the x. And if I take 3/2 times 2, I get 6 over 2, and 6 over 2 makes 3, and 3 minus 8 makes negative 5. And I'm done. I stop because I have my x answer, I have my y answer, so I can just write them down. So here it is with substitution, bread, meat, bread. So let me show it to you by graphing. Now, if I want to graph x equals 2, you have to remember x equals lines, I go to where my x is a 2, and all x equals lines are vertical because they only touch the x-axis. And then the other equation was y equals 3/2 x minus 8. So I went down to negative 8 on the y-axis. The slope was 3 over 2, so up 3, right 2, up 3, right 2, and right here, bam, that's where the two lines intersect, which is 2, negative 5. So Whichever method you like the best is the method you should use. If you like graphing the best, awesome. If you like substitution the best, perfect. Doesn't really matter. But these first three, I wouldn't have done any of them by elimination. They aren't really set up as nicely for elimination problems, so that's why I chose not to use that method at all. Okay, number 4. This one I did by substitution, and I mainly only did it by substitution because I didn't want to have to circle everything smushed with y and solve for y. I didn't want to put this in slope-intercept form. So I picked the equation where the variable was by itself. That was my bread. The other equation's my meat. And since this is what y equals, I plug it in the y. And then I just went through my solving equation process. I distribute the -3. I get to combine my x's when they're on the same side. Once I get my x answer, I plug it back into my bread. So since that's an x, I put it back in the x, and I get 1210 for my final result. Bread, meat, bread. So I could have done this one by graphing if I wanted to, but I'd have to get that top equation in slope-intercept form if I were to do that, and I just didn't feel like doing that. So substitution is the way I decided to do it. Okay, number 5. I did this one with substitution as well for the same reason as the last one. I didn't want to have to put the second equation in slope-intercept form. So my bread is the equation where my variable is by itself, and then I plug that into my meat. So since this is what x equals, I put the 3y into the x, and then from there it's just solving equation skills. Remember, when y's are on the same side of the equals, you get to combine them. And once I get my y answer, I plug it back into the y of my bread equation, and I get -6, -2 for my end result. Okay, moving on to number 6. If you ever have to pause me, pause me. I'm moving on to number 6. Number 6, I decided to do this one with substitution as well. Bread, meat, bread. So my bread is the equation where the variable is by itself. And since this is what y equals, I plug it into y of the other equation, and then just solve the equation. This time though, when I combine my x's, I get 0, so the x's are gone. All I'm left with is 10 equals 10, which is a true statement, and when you get that, it's infinitely many, or you can tell me all real numbers. If I were to have graphed these two lines, these would be two lines on top of each other. They'd be the exact same line. Okay, number 7. This was a problem that I thought was great for elimination, and it was already ready for elimination. If you see, the y's had the same number in front with opposite signs. This one had a -1 in front, this one had a +1 in front. So as long as it's same number, different signs, put your big plus sign and add all your columns. Once you get your x answer, you can plug that x back into either equation. It doesn't matter which one. I chose the first equation. And since it was the x, I plugged it into the x. And when I work it out, I get 10 -1 as my result. This one would have been more of a pain to do by graphing because I'd have to put both of these in slope-intercept form. And I wouldn't want to use substitution because I don't have a variable by itself at all anywhere. Okay, number 8. This was another one I did by elimination. My y's did have the same number in front but not opposite signs, so I decided to make my -9 in the top equation a +9. So I multiplied everything in the equation by -1, and that gave me this guy right here. And then you can see my y's now have the same number with opposite signs. So I put my big plus sign and I add all my columns. And then once I get my x answer, I just pick the equation that I want to use. Doesn't matter which one. And I plug the -1 back into an x. And I work it out and I find my y. And my end result is -1/3. 3. So these were great elimination problems. Okay, I'm going to go ahead and go to number 9. Remember, if you have to pause, you can pause. Okay, number 9. This was another wonderful elimination problem. So I decided to make my x's have the same number in front. I wanted to turn them into 4s. The top one was a -4, so I'm going to make the bottom one a +4. And so I do that by multiplying everything by -2. And then I just rewrote my equations over here. And then you can see my x's have same number, opposite signs. So I add all my columns. And once I get that y answer, I just pick an equation to use, it doesn't matter which one, and I plug the -1 back into a y. And when I do that and work it all out, I get x to be 8. So my final answer is 8, -1. Hopefully you already have these problems done and you're just taking a moment to check your work, and if you have a slight error in your work, maybe you can see where it is. Now, it is possible that you would have worked some of these problems differently than I did, but end up with the same answer, and that's fine. Okay, number 10 gets into some old stuff, into some review. So it tells me that I want to find the equation of a line that's parallel to y equals 4x plus 1, and I want it to go through this point. So what do we remember about parallel lines? What do you remember about their slope? Their slope's the same. Parallel lines have same slope. So I look for the slope of this equation here, and my slope is 4. So if I want to be parallel to it, I also need to have a slope of 4. So that's what I wrote off to the side here. This equation up here has a slope of 4, so my oh, you can't see that at all. Where did it go? Sorry guys, hang on. That was crazy. Okay, so this line right here has a slope of 4, so my parallel line also has to have a slope of 4. And then if I want it to go through this point, then I have to use point slope form. So remember, if you're ever given a point, that you're going to want to use point slope form. So off to the left here, that's what I wrote down, was my point slope formula. And then I just do what it says, y minus the y coordinate. So y minus a -7, which makes y plus 7, equals my slope, 4, times x minus the x coordinate. From there, I have to distribute the 4. And once I distribute my 4, I have to get y by itself, so I subtract 7 from both sides, and that gives me y equals 4x minus 15. You can see these two lines are not the same, but they do have the same slope, and that's why they're parallel. Parallel lines have same slope. Okay, this next one talks about being perpendicular. So what do we remember about perpendicular? Their slopes are opposite reciprocals. So this line has a slope of 4, which is understood to be 4 over 1. If I want to have the opposite reciprocal, that means flip and switch, flip the fraction, switch the sign. And what do you get? -1/4. So that's the slope that I want to use in this problem because I want to be perpendicular. So parallel lines have same slope, but perpendicular lines have slope that is opposite reciprocals. That means flip and switch. Hey, that means flip and switch. Yeah, flip the fraction, switch the sign. Now you've got it. Okay, and then because I want to go through this point, then I need to use point slope form again. So off to the side, I wrote down my point slope formula. I go y minus my y coordinate, so y minus 6 equals my perpendicular slope times x minus -8, which turns into a plus 8. Next thing I have to do is distribute my -1/4. When I do that, I get a -1/4 x minus 2. And then I add 6 to both sides, and I get y equals -1/4 x plus 4. And now I have two lines that are perpendicular because their slopes are opposite reciprocals. So these two are review, but some of you are still struggling with these. So hopefully this is helping. Okay, number 12. This is easy peasy. If I want to find the solution to a system by looking at a table, I just need to look to see where they have the same y-coordinate, and that is the point 12, negative 10. So wherever they have the same y-coordinate, that's where the two lines would intersect. That's where, if we were talking about companies charging something, this is where they would charge the same amount of money. Okay, this next one over here is actually number 13. It kind of got off a little bit. So, how many times do these two lines touch? These two lines, they never touch. So there's no solution. Or you can give me the 0 through the slash through it. Lines have to touch in order to have a solution, and these two lines never touch. So there's no solution at all. Okay, so this next page that has a number 13 on it, we're just going to ignore that because we already did it. So we're almost done here. Okay, number 14. This is one where I had to extend my lines. Let me pull that down for you. So I just looked to see what my slope was. I saw on this line here, it went down 2 and right 1. So I just continued that slope. Down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1. Plotted a ton of points. This one here, I saw it went up 1, left 3. So I just continued that. Up 1, left 3, up 1, left 3, up 1, left 3. And this right here, let me just go ahead and finish drawing these two lines. These two lines intersect right there, and that is the point 1, negative 5. So this kind of problem is easy. You just have to extend the lines. Just figure out what your slope is and just keep doing it over and over and over again. Okay, number 15. These lines were already drawn out, so all I had to do was look to see where they intersected, and right there is where they intersect. I just have to know its ordered pair, and it is negative 3, 4. Okay, two more. Number 16. It says if negative 6y is a solution to this equation, what's the value of y? Okay, this negative 6 right here is an x-coordinate, and if that's an x-coordinate, I need to plug it into the x. So that's what I'm going to do. I just put my negative 6 into the x, and then I just work out the equation and I solve for y. Very simple. You just have to know that that's an x-coordinate, so it goes into x. Okay, number 17, it wants to know if the point 8, negative 3 is a solution to this system over here. So if I want to know if it's a solution, one of the easiest ways to do it is just to plug it in. I don't want to show you all my answers. Hang on. Okay, the 8 is the x-coordinate, the negative 3 is the y-coordinate. So I plug 8 into that x, I plug negative 3 into that y, 8 into that x, negative 3 into that y, and I see if I get two true statements. So here I plugged it into the first equation. You can see my work. I plugged the 8 into this x, and then I recopied the minus. I plugged the negative 3 into the y, and I wanted to know if that made 11. It does. The minus the negative makes a plus, and 8 plus 3 is 11. So that one's good. Then I have to plug it into the bottom equation and see if it works. So you can see that I plugged the 8 into the x, I plugged the negative 3 into the y, and I need to see if this is true. So 2 times 8 is 16. 16 plus negative 3 makes a positive 13, not a negative 13. So since this one gave me a false statement, then no, that ordered pair is not a solution to the system. In order for it to be a solution to the system, when you plug it in, it has to make both equations true. It has to make both of these a true statement. And it didn't, so it's not a solution. And there it is. Hopefully you guys will be ready for your test and do an awesome job.